everybody, today our group will be presenting about the physics project for third quarter. My name is Natchareeya.
My name is Thanasawan.
And my name is Hamilton.
Today we're going to explain about fluid pressure, and the two principles that we'll be talking about is Dalton's law and Pascal's law.
The principle behind the fluid pressure is the Dalton's law, which is the P total equals to P1 plus P2 plus P3 plus P4.
The total pressure applied to a mixture of gases in a container equals the sum of the partial pressures of the gases inside. The pressure that a gas would apply if it were the only one in the container is known as the partial pressure of a gas. And for our experiment, we use syringes to demonstrate this law, so each of the 4 P that makes up the P total is 5. Therefore, the P total will equal to 20. We must make sure to have both the right and the left side of the equation to be equivalent, so these principles will work.
So the second law, which is the Pascal law. So the formula for Pascal law is force equal to pressure times area. So by pushing on the plunger applies pressure on the water in the movable syringe. Since the water is confined and incompressible, so Pascal's principle comes into play, telling us that the pressure is transmitted to all parts of the water and to all walls of its container. Since the plunger of the fixed syringe at the other end of the tube forms part of the container for the water and is the only part of the container that can expand, the pressure causes the plunger in the fixed syringe to move, and the pressure of the big syringe will be transferred to the 4 smaller cylinders, as the water pressure is confined inside the bottle. The only free space for the pressure that was applied to go is the free space of the 4 other syringes.
And now we come to the experiment part of the fluid pressure, and this is the fluid pressure model. As you can see that we have filled this bottle up to its very brim, and we also have 5 syringes as the main components of this experiment. So the bigger syringe is also filled with water, as you can see up here, and the 4 other syringes which are smaller and are the same size. So the thing that we are trying to prove from this experiment is that water from this bigger syringe can move the 4 smaller syringes. And so to do that, we're going to press this bigger syringe down. As you can see, water is slowly transferring to the 4 other syringes. And then if we put the bigger syringe up to its original space, water from the other 4 syringes will also transfer back upwards. And so this connects with the Pascal law, since the water pressure from this bigger syringe, once pressed down, it has nowhere else to go in this confined bottle since water is filled to the very brim. So the only spaces free for the water to travel is the 4 syringes. That's why when pressed down, the 4 syringes move. And as for Bernoulli principle, it also works with this experiment, since Bernoulli principle states that P total equals to P1 plus P2 plus P3 and plus P4. And so these 4 syringes are 5 ml. So 5 multiplied by 4 is 20. So this bigger syringe needs to be 20 ml for this experiment to work, as the 2 sides will be equivalent.